Today we're going to talk about translations, but before we talk about translations, I just want to mention the word transformation. So a transformation is when we change one figure into another figure. So a translation is a type of transformation, and we're going to discuss other types of transformations throughout this chapter. The new figure is called the image. The translation is also known as the slide, which you've seen in the past in your elementary days. And if it helps, the word translation has SL in it to help you remember translation slide. So I just want you to notice when you look at a translation, you see this figure here, this trapezoid, that basically is just being slid across the paper to become this one over here, which would be called the image. So the image comes from the original. This is where we would slide the translation over to. So pretty quick, we're going to go through some things that you've already known from the past. So when you look at identifying a translation, tell whether the figure on the left is a translation of the figure on the right. So what that means is, can I take this shape and literally just put my finger right on the shape and slide it down and over, and it gives me a shape that's the exact same size. It looks the same. It hasn't been flipped, turned, rotated, or anything else. It's just gone from here, down, and over. And I think it's pretty safe to say the answer is yes. This would be an example of a translation. Okay? They have to be the exact same size and shape, but they also have to be able to be slid across the paper in whatever directions you want to have them be exactly what they used to be when you started. So looking at the second one. So if I look at the second one, I would say this seems to be the same size. It is definitely the same shape because we have a rectangle. But could I just take my pen and put it here and slide it to this shape? Well, hopefully the answer you can say is no. It would have to be turned. So it has the same size, it has the same shape, but it has to turn in some way to become the other one. So that would not be a translation. So here you have the translation on a coordinate plane. So the first one in words. So let's just talk about this real quickly. So in words, we just talked about how a translation is a slide. What you're going to do is you're going to move the ordered pairs, which we remember from the past are x, comma, y's, where the x's go left and right, the y's go up and down. We're going to move our pairs left or right based on what the x is telling us to do, and up and down based on what the y's are telling us to do to produce the new image. So for example, in words, I might see something that says translate right 4, down 3. Now, if I look at the picture over here, this is showing us a picture of a translation where A, B, C triangle is my original triangle. How do I know that? I'm looking at two triangles, so how would I know which one's the original? Well, the reason I know this is that this notation right here, A with that little 1, actually reads as A prime. And A prime basically tells me that that's the new image. A, B, C, this triangle with these vertices named as just single variables, those are the original ones. A prime, this would be the new one coming from that. So how I do one of these. So we look back over here and we say translate right 4, down 3. So if I go to each of the points on my triangle, the directions just said 1, 2, 3, 4 to the right, 1, 2, 3 down, and notice now I have A prime. If I go to B, right 4, 1, 2, 3, 4, down 3, 1, 2, 3, there's B prime. And then for C prime, 1, 2, 3, 4 to the right, 1, 2, 3, down. So when I see them in words, I just follow the directions, remembering that on our coordinate plane, the x is over here, which does our left and right. The y's are over here on the y-axis, going up and down. Now the algebra part. This one's a little bit more difficult. If it's something that you grab, that's great. If it's something that you don't really understand, it's something that you can work on and get better at as you go through your high school years. So basically, we see the x comma y, and then we have this thing x plus a and x plus b. Well, really, the a and the b are really telling us, and that actually shouldn't be that. I'm going to get rid of that. That should really be y plus b. So hopefully you can make that change. So basically what it is a is how are my points being changed left and right, and the b is how are my points being changed left, up and down. So here would be our example. So our triangle ABC ordered pairs are x comma y's. So what we're going to do is we're going to say, well, we said to move it 4 to the right. So whatever my ordered pairs were, for the x values, I'm going to add 4. Because on the number line, if I add 4, it's going to push my number to the right. For the y part of the ordered pairs, down 3 would tell me I go minus 3. So it will drop it 3. Again, on the number line, as I'm going top to bottom, it's going to drop 3 to drop it further down. So let's just look at an example. So A. Looking at the ordered pair for A. A is sitting at negative 3, 1. So it's sitting at negative 3, 1. So the algebraic way would be to say, we would call this negative 3 plus 4, negative 1, positive 1, minus 3 would help me drop it down. So the A prime, negative 3 plus 4 is 1. 1 minus 3 is negative 2. So if I look over on my picture, 1, negative 2, there is A prime. So again, if you don't really understand how that's really all working in this algebra piece, try it. It'll make things a little bit easier when you get going further, but it's more important that we understand how to take the wording. If it says right 4 and down 3, we just take each of the vertice points and move them in that map to create our new picture. So now we want to look at how to translate one of these in our coordinate plane. So the first thing you do want to notice is that we want to get in the habit of kind of circling some information. We're going to translate it 3 to the right. That's important to notice. And 3 units down. And then we want the coordinates of our image. So it's always good to underline, highlight, whatever you can do to kind of figure out the information you have and what you have to do. So remember, here are my ordered pairs. I'm just going to show you the algebraic look to it, and then we'll fill that out in a second. If I do x units to the right, and I'm adding 3, remember x controls left and right, so I'd be adding 3 to the x coordinate. Then when I do the y value, if I'm going down 3, I would take my y value and subtract 3. So that's what the algebraic piece looks like. So let's now just show what it looks like on the coordinate plane. So remember, what I'm going to do is just go to each of my points and go 3 units to the right, 3 units down. So if I start with my A point and I count over 1, 2, 3 to the right, 1, 2, 3 down, there is A prime. And it's important that I label those A's and A primes. For B, 1, 2, 3, 1, 2, there is going to be B prime. And then C, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, down. Okay? Now, I am probably not going to draw this as well as I should. You should definitely be using a straight edge, which means a ruler, ideally, or the side of a book or something when you are trying to draw your lines, because they should be nice straight lines. This is never going to be straight in this. And then I forgot I need to label this C prime. So now coming back over here, I just want to show how this algebraic piece works. So based on what we just did, we could already answer this question. A prime B prime, and C prime. So when I look at my ordered pairs, A prime is sitting at 1, negative 2. B prime is sitting at 5, 2. And C prime is sitting at 4, negative 1. But let's just see how this other algebraic thing plays out. So A is sitting at negative 2, 1. So if I follow the algebraic part, negative 2 plus 3 would give me my new x value, and 1 minus 3 would give me my new y value. Now notice, negative 2 plus 3 is 1. There's the new x value. 1 minus 3 is negative 2. There's the new y value. So that's a way I can get there pretty quickly without even having to draw a graph if I could get away with just doing it without the graph. B is sitting at 2, 5. And again, if I run this through, 2 plus 3 is 5, which is what we had for the B prime. And 5 minus 3 is 2, which is what we got, 5, 2, for the B prime from the graph. And then lastly, C was sitting at 1, 2. So 1 plus 3 gives me my new x value, and 2 minus 3 gives me my new y value. 1 plus 3 is 4. 2 minus 3 is negative 1. Just kind of helps me confirm that we do have the right answer. The coordinates of our image, triangle A prime, B prime, C prime, are right there. For our last example, got a lot of words here, but again, if we pick through the words, it can help us figure out what we need to do. A landscape represents a park using a coordinate plane, which is what we can see to the right. He draws a square with the vertices A, B, C, and D to represent the location of a new fountain. So let's go ahead and do that first. So I want you to pause the video, draw what you think are A, B, C, and D with those coordinates, and then when you have that done, turn it back on and we'll keep continuing. So hopefully you have this picture. This is showing us the park that he is using. So what we want to do is we want to take this fountain in the park and move the fountain 4 units to the left and 6 units up. So then what we want to do is just follow the map. So if we take A and we count over 4, 1, 2, 3, 4 to the left, and then up 6, A prime is now sitting up here. So pause the video and you finish the other 3 ordered pairs and then turn this back on. So here you have the new image of where the fountain is being moved to. And again, I keep wanting you to notice this. This has not been made bigger. The fountain is not turned or been changed size-wise in any way whatsoever. It is still a square. It is still the exact same size. Now again, real quickly, I just want to go through this algebraic piece so you can see how this works. So again, left 4 units. So this time the x value, whatever the original x is, has to go to the left, which is minus 4 on a number line. And the y value is going to go up. And when I say up, we always add. So that's what the algebraic piece looks like. So looking at each of these, so A coordinate originally was 1, negative 2. So if I was to subtract 4, it now becomes negative 3. Adding 6 to a negative 2 makes it 4. So that is the new image point, the A prime. So B was sitting at 3, negative 2. B prime, when I subtract 4, is now at negative 1. Keeps moving on me here. And then when I take the negative 2 and add 6, I also get positive 4. When I do the C was sitting at 3, negative 4. C prime, when I subtract 3, when I subtract 4 is sitting at negative 1. And when I add 6, it is sitting at 2. And the last vertice D was positive 1, negative 4, and D prime, when I subtract 4 from 1, I'm at negative 3. When I add 6 to negative 4, I'm at a 2. So when it says to find the coordinates of the image, we have done that right here with the algebraic way, and also over here with the algebraic way in the picture. So you could have taken them off of there as well. So translations are all about sliding across your paper, up and downs, left and rights, not turning it, not flipping it, not making it bigger, not making it smaller. They should look the exact same as they did, but just someplace else on your paper. If you have any kind of questions, please feel free to let me know, and we will talk about this in school.